Greetings to one and all. I, Dr. Priya Mishra of GGIC Kalal Khedia, am going to present my teaching learning materials on mathematics. Consciously or unconsciously, we all use mathematics in our daily life. Few people find it a very difficult subject. Mathematics problem may be difficult to solve, but finding answers is really satisfying and fun. As a teacher, my role is to present mathematics as an interesting subject because maths gives new ways to understand the world. There is beauty hidden inside it which is inaccessible without some effort. Therefore, finding that beauty gives a sense of achievement and immense happiness. Moreover, mathematics gives us hope that every problem has a solution. So to start with, my first TLM is about magical ratio of A4. We all use A4 sheet in our daily life, but today I am going to reveal the mathematical beauty hidden inside this A4 sheet. This is an A4 sheet. When we lengthwise half it, we get an A5 sheet. That is, this is an A5 sheet. And if we keep on doing half of these sheets, we get A6, A7, A8, A9 and so on. And similarly, when we put two A5 sheets together, we get A4. And when we put two A4 sheets together, we get an A3 sheet. So, when we keep all the sheets in a way that their one corner is common, A9, A8, A7, A6, A5, A4 as shown in this figure, when I keep every sheet like this, we find that every sheet has a common diagonal, means all the corners lie on the diagonal. Now this shows that the ratio of length and the breadth of all the rectangles is same. That is the beauty inside it. And now why this is these ratios same? Now in this way we can introduce the properties of similar triangles to the students. As we can see, all these triangles, right angle triangles, are similar triangles. Now we can give them that problem that find out now the ratio between the breadth and length of all these rectangles. Now when we calculate, we find that the ratio of length and breadth of all the sheets, all A4 to A9 sheets comes out under root 2 is to 1. This same ratio implies that the photo or the text to be printed on the paper doesn't get stretched or squeezed no matter whichever paper we choose. So the change of sheet, we don't have to change the aspect ratio. And one can make a booklet of a particular size from a sheet of next largest size just folded in half. And also it becomes easy to calculate weight of single sheet also. Standard photocopier paper is usually 80 GSM, that means grams per square meter. Thus an A0 sheet being 1 square meter weighs 80 gram and A1 weighs 40 gram. This is all about the beauty hidden inside this A4 sheet. NEP 2020 emphasizes on the holistic education of the students that evokes their curiosity and creativity so that they can apply their knowledge beyond the curriculum. Hence, I present next TLM, that is Mobius Strip. It is a mysterious strip with unique qualities. So, when we take a strip and we simply fold it and stick it, we get a simple no twist loop. But to make a Mobius strip, we have to take the strip and give one twist. We have to give one twist and then we have to fix the ends. Now this Mobius strip can be made clockwise and anti-clockwise. That means this twist can be this way also, or I can give the twist from the other side also. So we can make two Mobius strips of different orientations. So, Mobius strip is actually why mysterious? It is mysterious because, see, in no twist loop, when we move on the surface, I can say it has two surfaces. One is the above surface and one is inside. When we move on the outer surface, we again come to the starting point after moving, and if I want to go to the other surface, we have to cross the edge. We have to cross the edge. So that means it is impossible to reach to the other surface without crossing the edges. But look at this Mobius strip. In Mobius strip, we can reach to the other surface without crossing the edges. I am moving on the outer surface and outer surface and then inner surface, and see, I have reached to the starting point. So now you can see this blue line is all over the page, even outside also and inside also. That means in a Mobius strip, we can move continuously on both the surfaces without crossing the edges. This is the mysterious property of Mobius loop. Now, when we cut half this simple no twist loop, what do we get? Two no twist loops, circular loops. But what happens when we cut a Mobius loop into half? When we cut a Mobius loop into half, we get a single Mobius strip of 4 twists. Now again, I am going to do another thing with this simple loop. When we join these two loops perpendicularly, that means one loop is like this, another loop is like this, and when we fix them and again cut them into half, then what do we get? We get a square. And when we join two Mobius strips of different directions, that is, one is clockwise and one is anti-clockwise, and when we join them perpendicularly, like one is like this and one is onto the other, after fixing them, when I cut it into half, we get two hearts interlocked into each other. When we cut two similar strips, that means clockwise or anti-clockwise, two similar twists of Mobius strips, when we join them and cut them into half, we get two different Mobius strips. So next we come to what are the applications of this Mobius strip. These are used as conveyor belts that last longer because both sides get same amount of wear and tear. Used in the tape recorders to double the play time. Used in printers and typewriter ribbons. Used in double track roller coasters. Used in sculptures and architectures because of its mysterious shape. Third TLM is a flexagon. Flexagon is a flat surface, two-dimensional structure, which here you can see there are two surfaces, but when we flex it in certain way, we can see the third surface. So because there are three surfaces here, blue, red and green, there are three surfaces that are visible. That's why its name is trihexagonal flexagon. I have also made a square flexagon. See, here it is pink color, red color, green color, yellow color. So there are a total of 6 colors. When we flex it again and again, we can see the different colors. In mathematics, we all know how to bisect an angle. My third TLM is about trisecting an angle. If I ask you how to trisect an angle using compass and scale only, then it would be a tedious task. That's why I have made an angle trisector. You can call it a small tool to make it easier to trisect an angle. Its shape is like this, and how do we trisect an angle? You have to see, if I have ABC angle, I have to trisect it. That means I have to divide it into 3 parts. Then I use it in such a way, I have to keep, you can see there is a slit here. I have to keep it in such a way that the vertex of the angle falls in this slit, and one of these, there are 3 holes shown on the top. One of the 3 holes should lie on one side of the angle, and the second side of this angle should be as a tangent to this semicircular side. So when we keep our angle trisector just like this, I have vertex here, one side is here, and this side is as a tangent to this part. Then we can make marks on these holes, and when we join these holes to the vertex of the angle get trisected. Without any difficulty, without any using compass, simply using this and keeping it in a proper way, we can trisect an angle. NEP 2020 emphasizes on the rootedness and pride in the Indian tradition. That is why I present my 5th TLM, which is based on the famous Indian mathematician Srinivasan Ramanujan. Now, here is Ramanujan's magic square. This tells students about Indian brilliance. He made a magic square using his date of birth, 22nd December 1887. So this is the magic square which Ramanujan created himself, and the sum of all the rows, sum of all the columns were same. Similarly, the sum of the diagonals was also same, and if we take the 4 consecutive corners and we add them, then also the sum was also coming same, 139. So this was named as a magic square. Now I present the method that every student can create his own magic square with using his own date of birth. So this is the formula. This is the square, and DD, that means you have to write your date, MM means month, CC means century, and YY means year. Here I have taken my own date of birth, 30/6/1976, and using this formula I have created my own magic square. So I always tell this to my students to create their own magic square. It gives them real fun. We all know about the Pythagoras theorem, and in every book, verification of Pythagoras theorem is done by making the squares on the sides of the right angle triangle, because it is easier to calculate the whole squares. But for the students of class 9th and 10th, we should tell them that if we make any regular picture on the sides of a right angle triangle, that is, if I make equilateral triangle or a regular pentagon or a regular hexagon, then also this Pythagoras theorem can be verified, and we can give them as an exercise to find out, to verify this Pythagoras theorem using other regular figures. Next, my 7th model is a tool in which student can remember in a playful method the values of the trigonometric values. We are rotating the upper circle and we are getting the values, like here it is set on tan. So tan 0 is 0, tan 30 1 upon root 3, and so on. So in a playful method, students can memorize the trigonometric values. Next, my model is about sum of interior angles of triangle is 180 degree. So this we can show, here I have made a semicircle and all these angles are actually equal to those. So we can remove, we can show, see this angle I can remove here and I can fix it here, and when we add them we get 180 degree. So this verifies that sum of interior angles of triangle is 180 degree. Similarly, we can tell them the sum of interior angles of the quadrilateral is 360 degree. 2 number 2. And if we fix all here, we can find out that sum of all the angles is 360 degree. Next, my TLM is about the properties of parallel lines. Now this is a kind of working model. Here, this transversal line can be moved, and as it moves, this angle also changes. So student can themselves see how the corresponding angles are equal, how alternate angles are also equal. So this is a model to tell about the properties of parallel lines. Last but not the least is my TLM. Here I ask the student to select the single perfect shape that fits all the holes. But to start with the easier, I tell them to find out one shape which fits all these 3 holes. In this way, the student use their imagination and they have a different perspective of all. One can say this is, but this is not fitting every. So, I tell them that this is the shape which fits every hole perfectly. So in this way they get an idea how to have the perspective of the things. Similarly, when I ask them find out which shape fits into these two properly. So not this. This is a three-dimensional figure which fits into these two holes very finely. Hence, my main objective of all my TLMs is to preserve the essence of National Education Policy 2020. All my TLMs try to inculcate skills such as creativity, critical thinking, problem solving, visualization and lateral thinking in the students. Thank you.